Hello and welcome to SQL Server Analysis Services 110 Dimension Usage. In this particular video I'm going to talk about dimensions and how they tie to measure groups or fact tables if you want to look at it that way. In previous videos you've seen creating a data source, then a data source view, then creating the dimensions and the cubes, and I spent a lot of time on modifying dimensions and setting up attribute relationships. One of the things I haven't talked a lot about is how dimensions tie to the measure groups or the fact tables, and how the cubes work behind the scenes in dealing with all these different dimensions when they have multiple fact tables. If you're coming from an Analysis Services 2000 world, one of the biggest differences in 2005 and 2008 is that a single cube can have multiple fact tables. Now, in 2000 you couldn't do that. You had to have separate cubes and then you could tie them together through a virtual cube. But in 2005 and 2008 a single cube can have these multiple fact tables. Now why would you have multiple fact tables? Well, there's really two common scenarios where you would want this. And generically it's one answer. It's that the fact tables have different dimensionality. Now that means that either they have slightly different dimensions. They may share time and product, for example, but then they may have other dimensions that are different, or they may have the same dimensional structure but have different levels of granularity within those dimensions. So I'll show you examples of both of these coming up in this video. Now, by default in 2005 and 2008, each fact table will get its own measure group. So one fact table per measure group, and that measure group will then have all of the measures for that particular fact table. So to use the Adventureworks example, I will show you first of all two fact tables, and then I'll add a third into it. But if you step back from the physical structure of this, the way the company is set up, it sells bikes and bike-related equipment. Now they sell two ways. One is over the internet, so people can log onto a website, directly order the product, and have it delivered to their house. The other way that Adventureworks sells is through resellers. So if you're in the United States, that might be a Walmart or a Target or some store like that. So people can walk into the store, buy the products, take them home. Well, if Adventureworks sells a product online, they know who the end customer is. So a fact for an internet sale has a customer. So there is a customer dimension for internet sales. However, for resellers, they don't know who the customer is. They just know that they sell it to some big store and that eventually someone comes in and buys it, but they don't know who buys it. So all they know is for a reseller sale, they know who the reseller is, who they sold it to as far as the company. Also, the way Adventureworks is set up is that if a person logs onto the internet and orders a product, there's no salesperson. Think about it. If you order something from, let's say, Amazon or Barnes & Noble, you don't deal with a salesperson. But if you go in a store, someone at least has to ring you up. Well, likewise, Adventureworks doesn't have salespeople who work on the internet, but on the reseller side they have salespeople that work to sell into the resellers. So they have someone responsible for Walmart or someone responsible for Target and pushing sales into those areas. So that's different dimensionality. Internet sale, we know who the customer is. There is no reseller and there's no salesperson. For reseller sales, there's no customer, but there is a reseller and there is a salesperson. So it's the same basic fact. It's a sale of one of our products, and so time and product will be the same, but the dimensionality is different because of customer and reseller and salesperson. So on internet sales and reseller sales, we have time. It's the same on both. We have product. That's the same on both. But then you see for internet sales you have customers, and then there are some others that I'm kind of ignoring for now. And then for reseller sales, you have resellers and salesperson, and then again some others that we won't worry too much about at this point. So that's the first main reason to allow multiple fact tables per cube. That is, facts that are relatively the same, certainly related, but they have a different dimensional structure. They have different dimensions. Whoops, went back. The second area is, you see a lot of times with forecast and actuals, and that is you have the same dimensions, more or less, but they're at different levels of granularity. So think about it. Adventureworks records sales at a daily level. Every day, every product, they know what they sold. But when they do a forecast, they don't forecast at the daily level. They forecast only at the quarter level. And that's really common. Forecasts are typically either at the month or the quarter level. So to physically implement that, the forecast facts do tie to the time dimension. They just do so at a different level of granularity. Same thing with product. You may not forecast at the individual product level. If you think about one of these great resellers selling office products, they probably don't forecast the amount of every size of paperclip they're going to sell. They just say, we're going to sell X number of paperclips, or they might even put it at a higher level of office supplies. So you typically will have in forecast or target data, whatever term you prefer, you'll have the same basic dimensionality, time, product, maybe some others, but they'll just be at a higher level of granularity. Now, when you go about setting up your cube, dimensions tie to these fact tables. And there are actually different ways of doing that. I'll just cover these briefly in the demo, but regular is just a direct relationship, just the normal type of relationship. I'll show you that. There is something called a fact relationship, and that's usually used for drill through. And drill through is when you have the aggregated data and you want to drill through to see the base level of data, the actual transactions. If you think about it, everything that you've seen so far is at the daily level of granularity. So if a person logged on to the website and placed 2 orders for the same product on the same day, that's 2 separate orders in your system. But you're summing to the daily level, so it would just show that person ordered that product that day and then the quantity. So you may not know if that's just in one order or multiple orders. Well, that's what drill through can show you. It goes and shows you that base transaction level. And there are times that you need to tie additional information into that, something that's not a measure and it's not part of a dimension, maybe a note. That's the kind of thing that you typically will use a fact relationship for. A reference relationship, I'll show you that, but that is when you want to have a dimension that's not directly related to the fact table, but you want to treat it like it is. And I'll show you an example of that with the geography dimension. And finally, there's a many-to-many type, and I'll describe that when I get into it, but there will be a whole another video on many-to-many dimensions at some point in the future. Finally, I'll talk a little bit about the unrelated dimensions. This actually is something that trips up a lot of people who are new to the Microsoft BI space. If you think about it for a moment, you have internet sales and they don't relate to a reseller. So what happens when someone is browsing the data and they're looking at facts from the internet sales fact table, but then they choose the reseller dimension? So I'll discuss what normally happens with that and then how you can modify that using this ignore unrelated dimensions property. So with that, it's time to jump into a demo and take a look at some of this in action. Now here I am in Visual Studio. This happens to actually be 2008, but it doesn't matter for this video. It's the same in 2005 and 8. And this is my data source view for the Adventureworks sample application. So I've gotten out of the one that I've been using and kind of building a simple one in the previous videos, and this is just the sample that Microsoft sends out. But what I want to show is that, of course, I have multiple fact tables here, you can see from the diagram. But the internet sales, so here's fact internet sales, and I'll zoom in on this in just a moment. But the key here is that I have dim customer, and so if I zoom in, because this is a sale on the internet, you see up here fact internet sales, and then you see a customer dimension. contrast that to reseller sales, and again, if I zoom in here, you'll see I have, in fact, reseller sales, but if I scroll down, I have an employee, that's the salesperson that I talked about, which I didn't have before, or I didn't have with internet sales. And if I come over here, here is the reseller instead of the customer. So at this point I have these two measure groups, and I have multiple dimensions. I have different dimensions for them. So what does this mean when it comes time to actually browse this particular cube? Well, let's go to the cube design and go to the browser. And once the browser is loaded, if I expand measures, you will see some folders here, and one is for internet sales and one is for reseller sales. Okay, these correspond to the fact tables that I just showed you. So for example, if I grab internet sales amount and bring it over, it does give me a value, 29.4 million roughly. Well, this again is valid data here. This is my total sales on the internet for all time for all products. Likewise, I can take my reseller sales, and it has a reseller sales amount. I can bring that over, add it as well. And you can see that through resellers I've sold roughly $80.5 million worth of items. Now, these are both valid numbers, and remember that both of these, the internet sales and reseller sales, tie to time and to product. So just as an example, I can grab from product here, I'll grab the product categories, bring it over and expand it, and both of those numbers are completely valid. I have accessories, bikes, clothing, and components. You can see I haven't sold any components on the internet. That's fine, just something I don't do currently in my business. But the rest of these do break down properly, and I still have my grand total here. Now I could go ahead and expand these and drill down to lower levels of detail, and all that works just fine. Now, let's take a look at one of the challenges that you have with this. Here I have internet sales amount, reseller sales amount. Imagine that someone comes along and says, oh, that's great, let's break it down by customer. Well, remember, we don't know the customer for reseller sales. So let me just grab the customer geography here and break it down, and notice what happens. The internet sales amount is broken down properly. But because the customer dimension doesn't tie to the reseller sales, it simply repeats the all level for every possible value. Now here that should be fairly obvious and easy to spot, but that's not always the case for your end users. They might look at this and start making decisions based on it. Okay, this is that ignore unrelated dimensions property that I was talking about a moment before. What this means is that the reseller sales amount measure group, the reseller sales measure group is ignoring an unrelated dimension. It says, I don't know what country is, so it just continues to show the all level. No matter what I do over here, what level of detail I go to, it's just always going to show that same value. It's just the all level. It's just ignoring the fact that, oh, I'm browsing some dimension over here that I don't know anything about. Well, you can certainly get rid of that behavior if you don't want it. Personally, I am disappointed that's the default behavior. I wish what I'm about to show you, the opposite of this, was the default behavior, but it is. Now, sometimes this is valid. If you think about it, you may have a forecast at a very high level of detail, and you may want it just shown everywhere that you happen to be. For example, you may have a corporate-wide value that your turnover rate should never be anything different than 15, or should never be above 15%. And then no matter what department you look at, how low a level of detail you go, it's just always 15%. That's the target. Well, that's okay. But in this case, this is probably not a good thing. So if I go back to the cube, then you can see this. I'll open up the properties window here. If I click on the reseller sales There is a property over here, I'll have to expand this a little bit, called Ignore Unrelated Dimensions. It's the property mentioned in the slide. And the default value is true. If you set it to false, it says I will no longer ignore those unrelated dimensions. Okay, so what happens now? Well, of course, I need to push this up to the server. So I'll deploy this. And it will go through and do a little bit of processing to grab this change, and then we'll go look at it in the browser. Okay, the processing has finished, so if I go to the browser, remember I'll have to reconnect because of the processing, and I'll go ahead and hide the window here. Before I reconnect though, I'll go ahead and clear this out just so you can see the magic when it actually occurs. So I'm reconnecting, and again I'm going to take my internet sales amount and my reseller sales amount. Okay, so far exactly the same as you saw before, and if I bring over product they'll behave exactly the same as before. But now I'll bring over customer and drop it, and notice now what happens is the reseller sales amount blanks for everything but the grand total. In most cases this is the behavior I prefer. I cannot tell you the number of demos I have seen people give on Analysis Services 2005 and 8 where they don't set this property and then they can't understand why. Oh, this number is the same for everybody. And in fact, I was recently teaching a class where some of the people in there had been using Analysis Services for a couple of years, and one of the guys later told me, you know, that alone was worth the price of the class for me. I've been trying to figure out forever how to get those values to disappear when it's an unrelated dimension. So, very simple property. The key again is just on the cube structure tab, you pick the measure group over here, and then in the properties you will find the Ignore Unrelated Dimensions. One of the challenges you will find with Analysis Services is that there are properties there to do what you want. You just can't always find them. Well, gee, is it on the cube? Is it on the measure group? And which tab do I have to be on? It's very challenging sometimes to find the exact properties you're after. Now, having gone through all that, let me talk about this next tab up here, Dimension Usage, because that's really what all this is related to. What you have along the top are all of your measure groups, and then down the side you have all of the dimensions. So I was just dealing with the internet sales and the reseller sales. So let me scroll around here a little bit and see if I can get them both on the page at once. Well, almost close enough. So here's the internet sales measure group, and here's the reseller sales measure group. Notice that they both relate to time, and I have three different, the order date, ship date, and due date, three different time dimensions. Now here's customer. Notice, of course, internet sales is related to customer, but reseller sales is not. Okay, it's just grayed out here. In a similar fashion, I have reseller, which is not at all related to internet sales, just a gray box, but it is related to reseller sales. And it goes from there. There are several other options here. So I want to talk about this. Again, I said there are several types of relationships, so let me describe those for you again briefly, and I'll go into more detail in later videos on some. But let's take internet sales and customer. This is a regular relationship. There's no icon anywhere in here. So if I click in here and expand this, you'll simply see a relationship type is of regular, and then the granularity is at the customer level, and what I'm doing is tying dim customer, this is the dimension table, the measure group tables, fact internet sales, and then what are the columns that are tied together? Well, from the dimension table it's called customer key, and in the measure group it's called customer key. That's really a pretty normal thing to have for a regular relationship. And this is what most of your relationships should be in a queue. Of course, in the reseller sales, I have a reseller link to the reseller. It's exactly the same, just a regular relationship tying dim reseller to fact reseller sales, and it simply ties the reseller key in each table together. Now, There are some other options. One other option is what is called a referenced relationship. Notice here geography is a dimension by itself. Now, when we're dealing with customers, we put the customer and the geography dimension together, those tables, in a single dimension. So you can drill from geography down to the customer. But on factory reseller sales, they do a reference relationship. And if you look at the diagram here, the yellow table here is the fact table. And, whoops, sorry, scrolled through that. The yellow table here is the fact table, and then up here are your two dimension tables. So it goes from the fact table to the reseller table, and from reseller to geography. Well, what that means is that we know the geography of the fact by knowing where the reseller is located. So in the fact table, there is no geography key. So we look up in the reseller, where are you located, and then we know the geography. Well, what happens is that if you tie it together with a referenced dimension and materialize it, what that does is when it builds the cube, it actually adds the dimension key from geography into the fact record, so that now it becomes a tie directly between those two. So you don't have to materialize it, and it can just do the lookup every time, but you'll get better performance materializing it that way. So that is a referenced dimension. I mentioned a couple of others. There is a fact dimension, which just says, hey, there's something in the fact table which looks like something we want to analyze on, some kind of attribute. And again, that's normally just looked up for drill throughs, and I'll talk more about drill throughs later in other videos. And I mentioned before this many-to-many. Now this is an interesting concept, and this was really difficult to do in Analysis Services 2000. Much easier to do now. If you think about it, the example in the Adventureworks application here is that when someone buys a product, they can list the reasons why they bought it, and it can be from 0 to many reasons. So you can imagine that you're buying something online and it has a series of check boxes. Why did you buy this product from us? Check all that apply. Well, when it says check all that apply, of course you may choose from 0 to all of them. So here the sales reasons might be best price, quality, you give great service, it was on sale, there was a gift, or it was a gift. I mean, you can imagine a lot of different reasons. And so for each order, there can be 0 to many reasons. And of course, each reason can be tied to 0 to many orders. So that's a many-to-many relationship between these items. And in short, this diagram is a little confusing, but what you have here is this first fact table in the upper right would be the fact for, let's say, the sales. And that might tie then to a reason and the product or the actual sale. And what happens is, to get that many-to-many, you create a new fact table. Sometimes this is called a factless fact table, but basically what it does is it ties an order to reasons. So it's just like in the relational sense, if you had a table of orders and a table of reasons, of course that's a many-to-many relationship. Well, that's basically what this fact table does. That's all it does, is take an order and tie it to 0 to many reasons, and of course then reasons tied 0 to many orders. So that's really all this does, and you just have to tell it what is this, what's called an intermediate measure group. And again, I'll do a whole video on many-to-many. There's a lot of things you can do with many-to-manys. This is the example in the Adventureworks database. There are others. Real quickly, you have an example of patients visiting physicians. Each visit, they typically call an encounter. A person can be given 0 to many diagnoses, and of course a diagnosis can be given to 0 to many patients. So you have this many-to-many relationship. The most common example you typically hear about, of course, are bank accounts. A bank account can be owned by multiple people, and a person can own multiple accounts. But let's say that you have a bank account with $100 in it and there are 3 people on that account. If you do a list of all of your people, you can't put that 100 next to each one. It would total to 300. Those 3 people together actually only have 100, but the account by itself is 100. So that's a many-to-many. And you see that a lot again. A whole video on that coming up. So that's what I wanted to show you with the dimension usage. This is how you come in and tie these things together. Oh, there is one more thing, of course. Back to the last thing to show you here, the sales targets. This is that target or quota that I wanted to discuss. So let me come in here and go to the sales quota. And here you'll see a fact sales quota table. I'll zoom in just a little bit for you here. And it is tied only to an employee and then a date, a time of some sort, and it's calendar year and calendar quarter. So all we're doing is saying for an employee, this is what they should sell this quarter. So we're not even looking at product here. This is just a real simple example. But the key here is that I'm tying to the same time dimension that everything else is using. But remember, time is normally down to the day level of granularity. You see that right here, the day number of week. And the date is actually just a date type. Well, if you look at this relationship here in the DSV, notice it's tying from fact sales quota to dim time, but now instead of actually tying in at the day level, I'm tying the year and the quarter fields together. So if I go look at that in the cube, in the dimension usage, and I look at the sales targets, which is right here, you see that instead of saying date here, it's tied at the calendar quarter. And if I expand that, you see calendar year ties to year, calendar quarter ties to quarter. So it will end up working exactly the same as I had before. It's just that I'm tied at a different level of granularity. So that's what I wanted to show you. I have an example of 2 measure groups at the same level of granularity but with different dimensionality. And now I have a measure group. It is different dimensionality, but it's tied at a different level of granularity to the calendar. So in summary, a cube can contain multiple fact tables. That's not a big surprise. And you have these multiple fact tables because somewhere the dimensionality is different. And in VI Dev Studio, it's the Dimension Usage tab. It identifies how dimensions tie to which measure groups. So which ones do, and then how do they do that. And then finally, you'll want to use that ignore unrelated dimensions property in some cases when you don't want the user to see the all level repeated if they happen to add a dimension that's not related to it. So with that, I'll wrap up this video. Thank you very much, and look forward to recording the next one for you.